All right, so first question we're looking at is for a parabola. We're going to discuss it by finding the vertex, the focus, and the directrix. But the first thing we have to do is get this part in that standard format that we're used to. And what number should always be in a parabola? Right there.
4.
A 4. So we got to rewrite that with a 4. And the number that's going to go in the parentheses, that is your A value. Okay. So what number would go inside the parentheses? 3. So that's our A value. That tells us how far away the focus is going to be from the vertex. It also tells us how far away the directrix is going to be from the vertex. Okay. Next thing we want to figure out is which way this parabola is opening. This is a positive value, and this is a y. What direction would the parabola open if it's positive y? Up. Yep, positive y means it's going to open up. So the parabola is going to have a minimum. And these values give you an idea of where the minimum is going to be. Remember, we have to think of them as being x minus a number. So if this wasn't a plus sign, we would rewrite it as x minus y. Because it's always going to be of the form x minus and then something in parentheses. Minus 4. So that is the first number in your vertex, minus 4. And what about over here? We would have y minus negative 2. Yep. So those are the coordinates of your vertex. Okay. Next thing is the focus. How many units did we say the focus is going to be from the vertex? 3. So here's your vertex. Your focus is going to be inside the parabola because the parabola has to wrap around the focus. And it's going to be 3 units up from the vertex. So what would be the coordinate if you went 3 units up from the vertex? Well, if you're just going up, one of these numbers has to stay the same. So we only want to modify one of them. -4. Right. So it's going to be -4, 1. And now the directrix has to be a line that the parabola bends away from. What type of line is the directrix going to be? Horizontal or vertical? Yes, it has to be horizontal, and it has to be down there. And how many units away from the vertex is the directrix?
2.
No, not 2.
And then 6.
No, not 6. It's symmetrical with the focus, the distance between the focus and the vertex.
So -3?
Yeah, it's still a distance of 3 units. So what would be the equation of the line that's horizontal and it's 3 units under the vertex? So what's the y value of the vertex now? -2. And we need a horizontal line that's 3 units lower than that. And how would you write it as an equation? Y equals -5. Yep. Because it needs to be horizontal and it has to be at -5. Okay, so for the next problem, we're going to look at an example where I give you a picture, and we're going to try to come up with the equation. So the first thing we want to do is figure out the general form, because there's 4 different ways that a parabola can open: up, down, left, or right. What do we know when a parabola opens up? What do we know about the number, like the 4 that's on the right-hand side? Is it a +4 or -4? Right, it has to be a +4 if it's going to open up. And what do we know about the letter that's going to be on the right-hand side? It's going to be a y. Is it squared or no? So think back to this one we did that opened up. Was the y squared on that one? No. So whatever on the right-hand side, that is not squared. Okay. So this is going to be a y. Now, how about on the left-hand side? What letter goes on that side? X. And is that letter squared? Yes. Now, they're both going to be a minus. And we have to figure out the coordinates of our vertex. Okay. What would be the coordinates of the vertex in that parabola?
4, 2.
Just look at it again. Three, 2. Yep. Okay, so we know our vertex is 3, 2. So what are we going to put after the minus sign in parentheses with the x? 3. And after the minus sign in parentheses with the y? 2. And then here, I should have left room for the a value. Let me give a little more space. What's the a value in this problem? Where a is defined as the distance between the vertex and the focus, or the distance between the vertex and the directrix. It's the same thing. 1. The distance between the vertex and the directrix is 1. So that is our equation. We could multiply 4 times 1 and just call it 4. Right? So that's how you come up with an equation if I give you the picture. Now, one other thing we could do with that is they might solve that equation for y, okay, on the test. So if we take that equation, x minus 3 squared equals 4y minus 2. What would be your first step to get y by itself? Move what? Since that's in parentheses, we can't touch anything inside the parentheses.
So we divide by 4?
Yep, divide by 4. So x minus 3 squared over 4. And what would be your second step?
Then you are 2?
Then we could add, did you say add the 2? Yep. So not saying they'll definitely do that, but they might solve an equation for a different letter and write it in a way that is just not exactly what we use, but they may rewrite it. Any questions on rewriting it like that? Okay, so let's take a look at finding the equation of an ellipse. I've given you the 2 vertices, and I've given you one of the foci. Now, what are the 3 letters that you always have to figure out when you're writing the equation of an ellipse? Yeah, you always have to find the A, B, C. All right. Now, what is the definition of A in an ellipse?
Is it the same as the parabola?
Mm, yeah. It's the same. But, well, we don't have a center in an ellipse. We can only measure the distance from, so yeah, technically no. I guess we use different words. Yeah, in an ellipse. So what's the definition of A in an ellipse?
So it's not the center to the vertex?
In an ellipse, it's the center to the vertex.
Oh.
There's no such thing as the center in a parabola. So, center to vertex. Why can't we figure out the distance between the center and the vertex here?
Because we can lose some.
We don't have the center, but you have enough information, you should be able to infer where the center would be. Where would the center have to be?
0, 0.
Right, because the center is midway between the vertices. So if you have one at 3, 0 and negative 3, 0, the origin is right in the middle. Okay, so now, what's the A value?
3.
3, distance between center and vertex. Is there another letter we can figure out from that information?
C.
C, yep. What's C going to be?
2.
Yep, center to focus. And now to write the equation, you need the B, but you can only find that indirectly. What's the formula that connects A, B, and C in an ellipse?
C squared equals A squared minus B squared.
Yep, C squared equals A squared minus B squared. So we get 4 equals 9 minus B squared. So what are we going to get when we finish solving that for B?
B equals 5.
B equals
Square root.
square root of 5. All right, so now we've got A, B, and C. Now we need to write the equation of the ellipse. What do we know an equation of ellipse is always equal to?
1.
It's always equal to 1. And we're going to have two fractions. What do we do with the two fractions in an ellipse?
Subtract them. Add them.
We add them. Yeah. So we're going to add them. And what do we always put for our first numerator in an ellipse?
Bigger number, or the numerator?
Numerator, x squared. And second numerator,
Y squared.
y squared. Now we need to decide between a squared and b squared and which one is going to go in which denominator. So how can we figure out whether we put a squared first or a squared second? Well, the bigger number is going to tell you something, but we have to figure something out first.
Where the vertices and the foci line up.
Yep, so we have to see where all the vertices and the foci line up. So we got to point 3 units up, 3 units down, 2 units up. How do all those points line up? What direction?
Vertical.
Vertical. So that means we want the bigger number under what letter?
Y.
Y. Yep. So we're going to put a squared under y. And we're going to put b squared under x. And that is the equation of your ellipse. Okay, so next one they're having us look at is finding the equation of an ellipse. First of all, let's write down the formula. What's the denominator, or what's the first numerator when your ellipse is shifted?
X squared minus h.
So we're going to do x minus h and then square the whole thing. Okay, and what is your second numerator?
Y minus K squared.
Yep. Y minus K squared. Okay, and what is the equation always equal to? 1. And because of the shape of this ellipse, what letter do we want under the x?
A squared.
We want the bigger number to be in the direction horizontal. Yep. And what letter do we want under the y?
A squared.
D squared. Okay. So all we have to figure out is the h, the k, the a, the b, and the c. We don't need the c. C would be for the focus. That's not going to be something we have to figure out. Let's start with h. What's the h value in this one?
Would be -5.
Yep, -5. So that's the x value of the center. And what about the k value?
2.
How much is that?
3.
Yes. So our center is -5, 3. All right, so we know what we're going to fill in for the numerator. Now we need the denominator. All right, so now we need to find a squared and b squared. What's the definition of a in an ellipse?
Distance from the center.
Center to,
The vertex.
yep, center to vertex. What's the distance from the center to that vertex?
3.
3. So we know a is 3. And what's the definition of b in an ellipse? From the center to where the minor axis would cross the ellipse. So this is your minor axis. So it's the distance from here to here. That's b. So b is 1. Okay, so now fill in all that information, and that will be your equation. So we're going to have x, it's going to become a +5 because it's minus minus. We're going to end up with a squared, which is 9. We're going to have y minus k, which is 3, squared, over b squared, which will be 1, equals 1. So that would be the equation of your ellipse. All right. So now they want us to discuss the equation of the ellipse. What are the 3 letters that we always have to find when we're trying to discuss the equation? We need A, B, and C. In an ellipse, how do you know which number in the denominator is A and which one is B? Right, you always look for the larger number. So this has something to do with A, but what do we have to do to that number to make it A? Take the square root of it. So A is 3. How about B?
B is
2. Yep, it's always the square root of the smaller number. And now we need the formula that connects A, B, and C for an ellipse.
C squared equals A squared minus B squared.
Yep, C squared equals A squared minus B squared. So that means C is going to be
Root 5.
root 5. Yep. Okay, so now we're ready to discuss it. Let's start with the center. Because the numerator is relatively simple in this one, there's no addition or subtraction, where does that mean the center is going to be? Yep, center's at 0, 0. Next thing we need to describe is the major axis. What's the direction of the major axis here?
Would it The vertical is the bigger number under the y.
Yep, in an ellipse, that's exactly what you look for. The bigger number, it's under y, tells us it's vertical. Yep. Now, how many units away from the center are the vertices going to be?
Is it A or B?
So from center to vertex, that is A.
So it's 0 to 3.
So it-
0 to negative.
Yep, it's going to be up and down from the center. So we can use that plus or minus because the points are symmetrical. And how about your foci?
0. Positive and negative root 5.
Positive and negative root 5. Okay. So there are all the important things that you have to describe when you discuss an ellipse. All right, so now they want us to find the equation of the hyperbola. Whether we're working with an ellipse or a hyperbola, what are the letters we always have to figure out first?
B and C.
We got to find A, B, and C. Okay. What would A be in this one? 3. It's the distance from the center to the vertex. And what about B? Well, I don't think we can do B directly. We'll have to do that one indirect. What about C?
5.
5, distance from center to focus. But the equation has a B in it, so we need the formula that connects A, B, and C.
C squared equals A squared.
C squared equals, what is it for a hyperbola?
Or is it A squared plus B squared?
A squared plus B squared. Okay, so now we'll fill it in. We get 5 equals 9. Oops. 25 equals 9 plus B squared. And what are we going to get when we solve that for B?
B equals root 16, which is 4.
4. Yep. Okay, so now we've got all the important information that we need. We have to figure out what we're going to plug that information into. All right, when we're writing the equation of a hyperbola, what do we know it's always equal to? It's always equal to 1. And we're going to have 2 fractions on this side. What goes between your 2 fractions? Subtraction sign. Now, this time, the first denominator is always the same. What is the first denominator?
Is this one always with y? Or-
No, x's and y's are always in the top.
Oh, the denominator.
Denominator.
Um, I'm not sure.
So what are the 2 letters that we used in the denominator for an ellipse? A and B. And if you had to take a guess, which one do you think would come first? A. Right? So with a hyperbola, it's like alphabetical order. A squared first, and then what would your other denominator be? B. B squared. All right. Now we have to figure out what goes in the numerator, and that's going to depend on which way the transverse axis goes. How do we figure out the direction of the transverse axis? Same way we would figure out the direction of the major axis. Same idea.
If B is bigger Or is it always the x minus y? Or does it switch?
It can switch. It could be the x first or it could be the y first.
So,
But we have to kind of figure that out somehow using these points. So what could we do with all these points? That would make it easier to see what's going on. Well, what's one thing you can do with coordinates? You can plot them. So let's plot them and see how they all line up. So that's what we do with the major axis, see how they line up. You need to see how these line up. So if you graph all those points, you have 0, 0, 5, 0, 3, 0, how do they all line up? They're all vertical. So what letter does that mean that we want first? The y squared. And the second letter? X squared. So now we know the equation we want to plug into. We have everything we need to plug in. Can you tell me what the equation of this hyperbola would be?
Y squared over 9
Yep.
minus x squared over 16 equals y.
This one. Perfect. Yep. And that's your equation. All right, so next problem they're giving us, they want us to find the equation of that hyperbola. Let's write down the equation template first, and then we'll know what we need to fill in. So when you are writing the equation of a hyperbola and the transverse axis is horizontal, can you give me the equation? Or can you give me some pieces that we know never change in a hyperbola equation? It's what? Well, we're going to use that to find the slope in a little bit. But we know that it's always equal to something.
It's always equal to 1.
It's always equal to 1. And what do we know about the other side? We always have 2 fractions. And we know something else that happens with the 2 fractions. We subtract them. What's always your first denominator? A squared. And your second denominator? B squared. And now the transverse axis goes which way in this hyperbola? Horizontal, which means we want what letter to be positive? X. So what are we going to put in our first numerator? X squared. Second numerator? Y squared. And the other thing that we know about a parabola where the transverse axis is horizontal is it has asymptotes. And what's the slope of the asymptotes? B over A. And it's positive and negative, B over A. Okay, so let's see if we can figure out what we need. Are there any points in that hyperbola that we could find the coordinates of that might be helpful? The vertices, yeah. So how far away are the vertices from the center? 4 units. And if they're 4 units away, that tells us one of the letters. What letter does that tell us?
A.
That tells us A. So now we know A is definitely 4. What's the other letter that we need to write the equation? We need B. So to find B, we're going to have to look at our asymptotes. What is the slope of our asymptotes? So I'm looking for the exact slope in this problem. So if it was 2 over 1, then our line would look more like this. It would,
So,
that would be up 1, right 2.
1 over 2.
1 over 2. So our slope is right 2, up 1. Okay. So right 2, up 1. So that's a slope of 1 over 2. So we know that the slope is 1 over 2. But what do we know about the a value? The a value is 4. So this slope is that we have, 1 over 2, that is a reduced version of the a and the b.
So B is 2.
So b would have to be 2. Yep. So now we know a is 4, b is 2, and if we fill them in, what would we get for our final answer?
X squared over 16
Yep.
minus y squared over 4 equals 1.
Y squared over 4 equals 1, and perfect. That is the equation of our hyperbola from a picture. Okay, so the last problem, they've given us a system of equations with 3 variables and 3 equations. So our first step is to pick 2 equations and then eliminate one of the variables in those 2. So what 2 equations do you want to work with first?
Um,
1 and 2. All right. So we're going to eliminate one of the letters in equations 1 and 2. What letter do you want to try to eliminate in those 2 equations?
X.
X, okay. So let's eliminate x. So we've got x minus y plus z equals 2. We've got 2x minus y minus z equals negative 6. And what would you have to do to these equations so that you could eliminate x?
Multiply the first one by 2, or
Negative
negative 2.
2. Yep. And if you distribute negative 2 in the top, what would you get?
Negative 2x plus 2y plus, minus 2z equals negative 4.
Okay, so negative 2x plus 2y minus 2z. Yep. And the bottom one we're just going to copy. So 2x minus y minus z equals negative 6. And what happens when you add your columns up?
X is canceled.
Yep.
Get y minus 3z equals negative.
Okay, so now that is a new equation. I'm going to call it equation 4, and it only has 2 letters in it. So now we need another equation just like that, with just a y and just a z. So we need to eliminate x again, but what 2 equations do you want to use this time?
1 and
1
3.
and 3. Okay. Okay, so equation 1 is x minus y plus z. Equation 3, 2x plus 2y plus z equals 3, negative 3. And how would you eliminate x in this one?
You multiply by the top by negative 2.
Yep, so we're going to multiply by negative 2 again. So that's going to give us the same thing in the top. Negative 2x plus 2y minus 2z equals negative 4. And in the bottom, copy it over. 2x plus 2y plus z equals negative 3. And what happens when we add those up?
You get 4y minus z equals
4y minus z equals negative 7. And now we're going to call that equation 5. Okay. So now we're going to use equations 4 and 5, and we're going to eliminate one more letter. What letter do you want to try to eliminate now in equations 4 and 5? Y? Okay. So equation 4 is y minus 3z equals negative 10. And 4y minus z equals negative 7. How would you eliminate y?
Multiply the top by negative.
And what do you get in the top when you multiply by negative 4?
Negative 4y plus 12z equals 40.
40. Bottom, we'll just copy it over. 4y minus z equals negative 7. And when we add our columns up here, what do we get?
The y's cancel, and you get 11z equals 33.
33. So that means z would equal.
Z would equal 30.
There we go. So there's our first answer. All right, so now we're going to take, I would take equation 4, plug in for z, and then we can solve for y. So y minus 3z equals negative 10. Fill in z. What's negative 3 times 3?
Negative 9.
So negative 9, which means y would equal.
Y equals, I got lost. Oh. 1, negative 1.
Negative 1. Okay, so now we got that. We can plug in y and z to get x, and I would plug into the top one. That one looks the simplest to me. X minus y plus z equals 2. So x we don't know. And what do we get for y?
For y, we got negative 1.
And when we plug that in, minus minus 1
Get positive.
plus 1. And for z, we got 3. So that means x will be.
X equals negative 2.
-2. And that's how you solve that system.